Hello, welcome to this MagiCAD for Revit ventilation module demonstration video. It's a quick overview of the features we offer in MagiCAD for Revit ventilation. This is a very quick overview, so we'll get straight on. First, we're going to look at some of the modelling tools that we have for Revit itself to help users save time when modelling in the ventilation services. So firstly, I'm going to look at the crossing tool. So in a situation like this where you have multiple ducts clashing with another duct or another object, let's say, what I can do is then just choose an offset. So I'll go here and here, choose the ducts I want to offset around the supply duct as well, choose the object I want to cross over, choose an angle, choose a tolerance for that, press OK, and then it offsets all the ducts at once, as you can see there in this view. So that's quite a nice tool to help you with that, save you cutting sections all the time and spending lots of time. As you can see, that's a matter of seconds to do that rather than 5 minutes in a Revit section times by 3 ducts. So the next tool I want to look at is the horizontal crossing. This is a situation where you have a clash, like I say, in the XY plane like this, where you've got this situation here. I'm just going to choose an offset there, choose my reference point, offset around, and then you can see there I've now got a tolerance of 50 mil. There's my angle. I can choose 45 degrees, it'll update it, but I'm going to stick with 30. Choose arrow to flip it so you can mirror the offset around the other side. If you're happy with it, press OK, and you can see there it's now offset the duct in the around the vertical one in the XY plane there. So that's quite a nice feature. Next one I want to look at is standard connection. So if I click that, I can then choose to connect this duct into the other duct there. I can choose my standard angle that I wish to connect into, so you can see whether it's a 90, 45, 60, doesn't matter, and you can also choose whether it's a T or a tap. So I'm going to choose a T, that situation, press OK, and there's my standard connection. It's rotated the fitting around to suit, as you can see. So again, it's quite a nice tool to save having to cut a section and rotate the fitting manually. The next tool I want to look at is the angle to horizontal. This helps you come off ducts at a certain angle to a certain height. So in this case I want to go, say, underneath this supply duct here, maybe at 30 degrees, got 100 mil offset, press OK, and then choose the side, and it will put the angle on the fitting to come off, and then away I go. And then you can see there we've now gone underneath the other duct by the 100 mil offset as prescribed in the previous dialog box. Just going back to the standard connection as well, there's another situation where that works, which is pressing that and then using the tool to connect, let's say, a bend into this duct up here. It's quite an awkward thing to do in maybe Revit command, but with this you can actually see that it works fine. It converts that bend into a T and puts a T on there. Again, you can always change it to a tap as well. Choose an angle, maybe 15 degrees this time, press OK, and you can see that it's now done that connection to that duct at a higher level to there. So there's another use for that standard connection there. The angle to horizontal also works with drops off the end of ducts, so I can come off the end of here and then drop down at a certain angle to another height. I don't have to use other objects to reference it. I can just type in here like 1700 to the bottom of the duct at 30 degrees, press OK, and you can see now that it drops off the end, and I can then just route that ductwork around, and you can see what it's done. It's just dropped that at 30 degrees as stated in the previous dialog box. Continuing on, I just want to show a few more things in the modelling tool toolbar here. So device connection, click on the device, the air terminal, click on the duct I want to connect into, and you can see that we now have a connection being made there from the grill to the duct. I I can choose my standard angles, I can choose whether I want a tap off the side of the rectangular. Also a very nice feature, you can choose flexible ductwork as you do this, and I can change the length of it and then press apply and see what effect it has on my solution. Press OK, and then there's my ductwork there, or with the grill on the end of it with the flex there. So that's that tool. We also have an eccentric reducer, which helps you get out of a sticky situation sometimes if it's an awkward, like there's an offset in the vertical and in the XY plane there. You can see it's quite an awkward situation to have to connect together. Press eccentric reducer and connect these two things together, and then we can then connect the two ducts like so, in like a sort of bespoke piece of ductwork between them. And then what I want to do now is look at the duct drawing tool. So click on ductwork there. If I now show you the contents of this, you can choose Revit system types on the left hand side. You can choose which ductwork families you want to choose to model in. You can choose whether it's a T or tap from this menu here as your model as well, rather than going to route and preferences in Revit all the time. Choose your size. You can actually model insulation here as you draw the ductwork, so you can actually include the insulation as you go, which you can't do in normal Revit. You have to add it afterwards. So that's a very big plus for this tool. And then with this you can also set as normal. You can just put your normal offset in like in Revit, but you can also in this choose the bottom of the duct, and you'll see the other figures update in relation to the diameter, like so. And there's some tools down here as well where you can say I want to justify or run my ductwork on top. So if I click justify, I can justify, say, this duct, this circular duct, top to top of this rectangular duct. So what it'll do, it'll even take into account the insulation thickness for both the reference duct and the ducts I'm drawing. You don't have to worry about these other figures in here, rather than having to calculate them manually in Revit or in your head or in a calculator. So you can just click with confidence and then draw the duct as you wish. And then if we go into that section view now, you'll see that it's now justified the top of the duct to the top of the duct, taking into account the layer of insulation as well. It's exactly what we wanted. Another use for that tool is when you uncheck that box, and now I can go on top of, say, this duct, this supply duct, with a 50mm tolerance. Press OK, and then this time I can just draw straight across the top of there. Go back into the section view, and you'll see that it's now drawn this duct above with a 50mm gap in between there. So that's a summary of the modelling tools that we offer in the MagiCAD for Revit ventilation module. So we're going to move on now into the calculations. The MagiCAD for Revit ventilation calculations enable the user to perform sizing of ductwork and balancing, which includes pressure drops. Calculations within Revit itself. The calculation is performed within the Revit environment, so you don't need to export or leave Revit itself. So you can see here that we can perform this calculation on this stage 4 detail design system here, should you wish to. But I'm just going to show you quickly how you do the sort of stage 3 or stage 2 maybe calculation on just distribution ductwork. The idea of this being that you can save a lot of time by only sizing your main distribution ductwork without having to connect every branch to every single outlet or grill or device, because that way you would over deliver, which is a big problem at stage 2 and 3. So what MagiCAD does, it enables you to put connection nodes onto the end of ductwork here. So if you click on that duct, I can call this a reference, I can give it a flow rate, I can give it a pressure drop downstream from this point, press OK, and it puts the node on the end. I then tag it, and then you can see there they've now got this effectively a representation of a system down from this point. So all I'm doing here is putting these connection nodes on. Then I go to calculation sizing, choose my criteria I wish to size the ductwork on. If it's rectangular, I can put some restrictions for heights and widths as well, and then just click on there. Then we get a report. This report highlights all the different aspects of this system in every single component on there, and you can see if I want to zoom to it, highlight and drawing, it will zoom to that component in there. and then it gives me my proposed sizes and flow rates and velocities. If I'm happy with everything, I just press OK, and you can see now it will resize all the ductwork. So you can see it's resized it in line with that criteria. It's a very quick way of performing your stage 3 performance designs or early stage designs, and you can see you can save a lot of time by doing this particular task. Anyway, on to stage 4 detail designs. It's a similar idea, but this time I've got a fan connected, the ductwork distribution around here, and then go into the final outlets or the grills. So what I need to do now is perform that same sizing task on here. So there's my criteria, press OK. Again, I can interrogate this report and see the projected sizes and flow rates and velocities. Press OK, and it should resize my ductwork. You can see it's 15 meters a second now. It now goes to 3.8 because I've now resized the ductwork in line with the criteria. Then what I want to do is do another calculation on the balancing, and balancing is a pressure drop calculation, but it's more than that. It also balances the system. When you put VCDs in there, it'll also balance it in accordance with those. So if I click on that, it's going to perform a pressure drop calculation with the index run highlighted in green. You can see it goes to that terminal. That also lines up with the green here. I can right click, highlight in drawing, jump to it there. I can interrogate any part of this report. It's completely transparent, so I can go into the bend, look at the pressure details. It says the flow rate, pressure drop, K factor, and also the CIBSE Guide C guide plus the table or tables it uses to reference that K factor. So it's all totally transparent. You can look at any of the figures for velocity, flow rate, pressure drop, anything in there. But then you can also copy to clipboard, which means you can paste that into an Excel sheet if you want to do that. Also, you can print it to a PDF or a hard copy as well. And if I do that, I can then load that up and show you very quickly. It brings all the Revit data from the project in terms of the project information from Revit. It tells you what system it's on, total flow rate, standards, total system pressure, and the air data. Then below there it's got all the components you wish to have and all the data about it on the right hand side in the column. So very transparent, very complete way of performing a calculation. And for QA purposes, then obviously you could put that in your QA file as a report, so you've got a record of what you did at a certain date in time, which is very important with a ever evolving Revit project. Update the model, and you'll see that we now have the pressure data associated with that now inserted into these fields. So it automatically updated the tags, which are ductwork tags, showing that as well. Next thing I want to show you is a sound calculation. I can do that, and I can see it will use the sound data from the system. So we'll use a sound data. Here's a fan with the extract system with the fan curve there and the sound spectrum below it. It will use that data in this calculation and then use that to calculate the sound levels at the grills. You can see here these have the sound level there, and all I need to do now is, once I've done that, is perform a space sound calculation, which will then use the data from the project to calculate the sound levels in the spaces at a certain absorption coefficient or reverberation time, and then press finish, press OK, and you can see it's recalculated the sound data, and you can put a legend in there and color code it as well if you want to do that. And if you add an attenuator in there, or you rearrange the system, or you put a different fan or flow rate, then clearly everything will change, and then you can just run that calculation again. So like I said, it's a very complete calculation engine there for you. So that's a very quick run through the main calculation features for MagiCAD ventilation module. But once you've done the calculations, if you want further ability to check the data that's been used in the calculation itself, and also for QA checking, if you create a view with a duct legend, and because you're doing design in Revit now, you can see here that the tags are there as before in the previous view, but this view now has different color coding for different ranges of velocities. So if you're concerned about a certain range or don't exceed a certain velocity, then all you do is put the colors in the legend and then check it against your color coded ductwork in the view itself. So with this combined, this is a Revit feature, it's not a MagiCAD feature, but when you're using designs in Revit, then obviously it's very powerful in conjunction with the MagiCAD calculation report output, so you can get very, very straightforward, clear, transparent checking of all your calculation results with this, and obviously the report output as well. Now we're going to look at installing products from the MagiCloud, which is our online product library. For example, let's click on install product. I can see here I have an attenuator that's in the data set already, which is part of the product library here, just a circular spigot rectangular attenuator. So I press OK and I get a floating toolbar, and then now I can choose how I want to insert it with this some of these smart tools here. So there's auto size, so I'll just click on there, and then you can see I've now just dropped the attenuator automatically onto the duct with the matching spigot size for that 200 diameter. So that was just installing an attenuator. Let's look at installing maybe a supply grill. So again, go into here, this time I'll look at the MagiCloud so you can see how this works. So we go to this online cloud database, and in here I can type in a manufacturer I wish to search for, say Trox. I can go to the maximum spigot size that I want to search for, something like that, and you'll see below we have all the grills that match that criteria. So just for demonstration, I can see this one. You can look at the image, you can look at dimensions, there's the graph of the performance, click insert, and then now it becomes part of the product library in here. So you can see it's now this grill in the data set. Press OK, and there it is, and then there's my airflow. So I can put, say, I don't know, 55 litres per second. You can see that it jumps to that point on the graph with the spigot velocity shown there at 2.7 pressure drop. And if I'm happy with that, I just press OK, and now what it does, it just downloads that product from the internet and converts that to an RFA family in Revit. So the next thing will be to insert this directly into the project. You can see here we do have a floating toolbar which you can install to end of ducts, side of ducts, and also an array function, so you can actually do other things like install this in a space, and I can just select a space with some settings, like I can put 2 by 1 and then click on the space and it'll put 2 grills in, as you can see, like that. And you can constantly just put 4 in, put 2 by 2, and you can see again that updates that like that. And as soon as you press apply, then that's finished. So press apply and it's in there, and then just press free end again, and then I can just insert that grill into there like so. Press apply and then it's in. So there's the grill sitting there. And as usual, just to show the whole process, if I just press device connection, click on the grill, click on the rectangular ductwork I want to connect into, then once again there's the solution for connecting it up, then with some flexible ductwork at the end, and there we are. That's how easy it is to bring products in from the cloud, convert to RFA, install it to the project, and then connect it into the system. So that was very simple. Of course, the other thing I mentioned before was installing RFAs into the project that are actually being created by yourselves or from another manufacturer that aren't part of the MagiCAD library. It's not a problem. They work with our calculations. You can still size ductwork, size pipework, etc. using them. The only thing you'll lose is the intelligence of that particular product. In here you can see the MagiCAD product has a associated dynamic data with it. Here's a family I downloaded from the internet here, just another fan coil unit. If we go to properties, obviously it doesn't have the dynamic data that MagiCAD products have, but nonetheless you can still design with it. So if I go to calculation and balancing, if I just click on the fan coil unit itself that's connected to the grills, you can see there MagiCAD still knows it's a fan coil unit. You can see there it's a fan coil in the type here as well, and you can also see that it puts the index run down to here, and it does a pressure drop calculation should you wish, and that's also applicable. It's got the piping connections that also work with the heating and chill as well. So there's no restrictions apart of using your own families at all. You can enter your own pressure drops and things like that for grills as well on the connectors, so all works very nicely. Only thing, as I said, you don't have the dynamic data that we provide, which is the big advantage of the MagiCAD library of products. That's the end of this demonstration video. Thank you for your time. You can see on the screen now ways of getting in touch with us in the UK by email or phone. So please get in touch and we can provide any more information you require. Thank you very much.